Getting into some more complex examples of string instruments, let's take a look at this string that has a length of 80 centimeters, and we see the wave shown. You're told that the wave speed is 220 meters per second. Your goal is to find the fundamental frequency. So that wording is actually a little bit odd. We can get rid of this right here. Find the fundamental frequency of the string would be a better one. Apologize about that. So let's take a look at what we have. We have two waves, or 1, 2, 3, 4 loops. 4 loops equals 2 waves. Okay, we can also say we're in the fourth harmonic. So let's solve what this frequency is right now. V equals lambda f. The speed is 220. The wavelength is 40 centimeters. I have 2 full waves here, making 80. So one wave would be 0.4 meters or 40 centimeters. Now I can take my calculator. I'm going to go 220 divided by 0.4. I get 550. Now remember, that's the fourth harmonic. So 4F naught is 550. So F naught would be 550 over 4, which is 137.5 hertz. My next and last example, let's say we have a 60 centimeter long string, and when it's at the fundamental frequency, it vibrates 250 hertz. So the question is, how long do we make the string in order to give it a frequency of 280? Now, if you notice an instrument, say like a violin, it has 4 strings. So that would limit dramatically how many frequencies could be generated on this string. So what we do is we simply place our finger on the string. By doing so, if you put your finger, say, right here on the string, this portion of the string vibrates, well, this doesn't. Now, in the process of doing that, you will not change the speed of the wave, but you will change the effective wavelengths. So the question's ultimately asking us, how long is this? So let's start with the initial string, which we do know to be 60 centimeters in length. V equals lambda f. The speed is not going to change. So, whoops, I made a mistake. Our wavelength is 1.2 meters. Remember, what I would have is half of a wave spanning 60 centimeters. So the full wave would be 120 centimeters or 1.2 meters. The frequency is 250 hertz. So I go 1.2 times 250. I get 300. So 300 meters per second is the speed on this string. As I modify the string by making it shorter and pinching it here, the speed will still stay 300. So V equals lambda f, 300. I want the frequency to be 280. 300 divided by 280, 1.07 meters. Now that's the wavelength. So again, we're only seeing half of the wave here. So to conclude, I'm going to take the 1.07, cut it in half, get 0.535 meters, or 53.5 centimeters is how long I want the string to be.